So it's the second to last session of the day. So I hope your brains are turned on. We've got some machine learning, maybe math, maybe not. We'll see. So who in here is a machine learning expert or a data science expert? Oh, good. I'm not alone. OK, so I am not an expert in machine learning. I've played with it a little bit. But we're going to be using an API that lets you access a pre-trained machine learning model. And I'll explain a little bit about what that means. So my name is Julia. I'm a software engineer at Google. I work in the open source programs office. So I write tools that help folks at Google release open source software. Which means that I have to say things like this in that the code in this presentation is already up on GitHub and it's licensed. So you can use it. So apart from that stuff, I do some weird things about connecting up technology in unusual ways. So I used machine learning to basically categorize all of the scotches that I could find. I learned how to pronounce some things along the way. I was hoping to build this Scotch recommendation system, but it turns out I just need to drink more Scotch, and then I'll find out more about what I like. I play a lot of Minecraft, so I like to run multiple worlds at once. So I did some stuff to orchestrate multiple Minecraft worlds. But my favorite is I have a hard time figuring out if something is something that I should hug or not. So I took a bunch of examples, and I trained a machine learning model that takes an image and tells you whether you should hug what's in it or not. So I'm happy to say that it worked pretty well on things like stuffed animals, but it gave me some false positives for things like bears. Don't hug a bear. I promise it's not going to end well. So when people tend to think of machine learning, you all, I'm pretty sure, believed somewhat that there was going to be a ton of math in here. And people tend to think of it that there's going to be a ton of math. And it actually is true. If you're developing machine learning algorithms or using machine learning in its more flexible form, there's going to be a lot of math, a lot of linear algebra. And people kind of get scared off of it. But there's actually no rule that says that you have to have a PhD to use machine learning. In fact, we've got a lot of open source toolkits now, TensorFlow, to name one, that allow anybody to use the machine learning algorithms that have been in development for decades. So machine learning is a lot of math, but using machine learning can actually be as simple as this. You've got a bunch of data. We've been collecting data for a long time now. We didn't really have the infrastructure to host it or to process it until pretty recently, or the average person didn't. But we take that data, we run it through some sort of algorithms that somebody has developed to answer a question. And as I mentioned, data has always been a big challenge. When I was working with data sets in grad school, I think I was working with ones that were less than a gig. That's really, really tiny in today's terms. So with the advent of data, we've been collecting, we've been logging, and we've been keeping that around, thank goodness, because now we can run it through the machine learning algorithms that can all of a sudden be much more powerful. But of course, you need some place to run it. So you can do really cool things like this. This is style transfer. So I'm taking a starry night, applying it to a picture of a starry night, and getting a stylized version of the second image. Who here has used Prism? I love Prism. Prism's awesome. They recently updated it to do onboard processing, which is super impressive. But they're a classic example of style transfer on your own pictures. Or Google Translate. I use Google Translate a lot because the only languages I speak are programming languages. So Google Translate is an example of machine learning, machine translation, that has built up a model of how to translate from one language to another, in this case, English to Italian. Because I'm a former classics enthusiast, you can see I often translate back and forth from Latin to English, which didn't work so well on the internet for some reason. So now that we have a bunch of the data, does that mean it's not a problem anymore? Turns out the data is still the problem. They like to say that if you have a difficult data science problem or a difficult machine learning problem, it actually doesn't boil down to the algorithms, it boils down to the data. Because if you change the data and you run it through the same algorithm, you're going to get a completely different answer. So if you have bad data, you're going to get bad results, which is unfortunate, because not everybody has access to a great deal of data, which is where this idea of moving the model into an API comes from. And I like to say machine learning as a service, but more accurately, it's machine learning models as a service. So the folks who offer these, Google included, what we've basically done is we've taken a vast corpora of data, and we've gone ahead and sanitized the data. We've made sure it's in the right format, which surprisingly is still one of the really big problems in machine learning. And we've gone ahead and trained a model using those nice, awesome algorithms that have been in the works for a while now. And this can take a while. It's going to be a distributed training, and it can take a while, even to retrain. But then you make those available through an API, and then anybody can use them. You don't have to have a PhD. You don't have to have the extensive training. All you have to do is know how to make an API call. And if I don't want to insult anybody, but how many of you know how to make an API call? Just a few more than considered themselves a machine learning expert. So it's much more accessible to everyone. And I know enough machine learning to be dangerous, so I know how badly I can screw things up, which means that I'm going to be much more inclined to use an API that just accesses a model that's already been trained. OK. So this was great. And this is something that we actually released. I've talked to a few of you outside. But one of the APIs that we've released is Google Cloud Vision. So you throw it an image, or you connect it to like a bucket and have it just kind of go through the images that are there. And you can ask various questions of the images. What are in them? Are there people there? Where are the facial features for the people in them? Are they happy? Turns out you can detect sentiment on images. And we know that sentiment analysis on text is a pretty well-worn path, but sentiment analysis on images can be much harder. But it's just an API, and all you have to do is tell it what you're looking for, and it will get back to you. So when I was trying to think of how I could use the Vision API, because I had a lot of questions. I have a lot of pictures, and I have a lot of questions about the pictures. They're all on my phone. I was the person that said they would never solely move to using a phone for their pictures, but I did. And so they're all there. I don't want to have to go and upload them to cloud storage. I don't want to have to, one by one, make the API call. And I wanted to be able to ask questions of my pictures in a way that I do currently on my phone. So if you are looking for an expert opinion on your phone, I know that when I do it, I go and I find somebody on my contact list, and I say, who knows more about this than I do? Usually it's my sister. I ask her a lot of questions. So why not connect Twilio to the Cloud Vision API and have a nice little app that tells you information about the picture that you just took. It seems pretty sensible. So what I built was exactly that. So you have your phone, it takes a picture, you text it to your Twilio number. It then routes to a Flask server that I have running on Google Compute Engine, which is our infrastructure as a service. So I just have a VM spun up there, and Twilio sends the image there, which then queries the Vision API and gets back to us, and we just complete the cycle. Once we get the information about what's in the picture, we go ahead, we construct a response, and send that right back in thread to the phone. Pretty simple. So all told, this little app took me about an hour to create. I think that's a testament to Twilio, and I think it's a testament to the ease of calling APIs. So let's go through a little bit of how this is possible. Again, this is all code that's on GitHub, and I'll provide a link after the presentation, so don't frantically copying anything down. So as I said before, it's just a Flask server. So what we have is the primary receive message method here. We go through and we pull out every image that's been attached to this MMS. We go ahead and we fetch the content. We're using a requests library here if you're not a Python aficionado. And then we're going to go ahead and process the image using Google Cloud Vision. And we'll go through this. So this labels get image or get labels is where some of the magic takes place. So let's dive into that. It's a pretty straightforward flow. You could probably be a little bit smarter. And for the sake of, I don't want to raise anyone's engineering hackles here. So I have omitted some of the error handling for the slides, but they're in the they're in the repository, I promise. I've caused enough errors to know that, promise. Okay, so we first go ahead and we authenticate with Google. And this is just saying that we're using the Vision API. We're going to go ahead and authorize ourselves and build up the service. So I skipped over this earlier, but what we do when calling the Vision API is we base64 encode the images. And we do that before we send it to the API. So then we construct the message. This is just your basic JSON. We give it the image content, and we tell it what kind of question we want to ask. So here we're going to talk about labels. And label detection is a really basic feature of the Vision API, and it tells us what's in the image. If you have a fluffy bunny, it will tell you that there is a bunny, perhaps maybe with the descriptor of fluffy on there. And with that, it will give you a number between 0 and 1. And that 0 and 1 number is really important, because what it is the score for that label. It's not a zero sum. Each label is scored independently. So if you have a number closer to 0, it means it's not very sure that this label is accurate for the image. If you have it closer to 1, then it's pretty good. It's pretty sure. So once we go ahead and send that request off to the API, we go ahead and execute it, we will get a response. And then we have to go and parse out what's in the response here. So we iterate through, and we get all of the label annotations associated with that request. So if you're making a complex request to the API, you could look for labels, you could look for sentiment, And you could look for, what else can we do? You could look for OCR. You could try and do an OCR operation on the label, on the image. And if you did that all at once, you'd have to parse through a little bit more carefully. So if the API found something, something will be in that object. Otherwise, unfortunately, there's no dice this time. This is if you are a gamer, these dice should be very familiar to you. OK, so once we have the labels, we'll go through and construct the response. I like to put really snarky responses in my texts back to myself, which I'm told might not be super appropriate, so I took those out. Sorry. So we go through, we parse out the score, that score that I mentioned, and the description for the label. And we create our text message. I limited it to 3 labels because I don't really appreciate getting very, very lengthy text messages. So we could talk for ages about what's in an image. I don't want to give you 1,000 words. So we'll go through and construct our Twilio response, and then send it. That's pretty much it. So let's do a proof of concept, show that this proof of concept actually works. OK. So I've got my application running, let's hope. Let's hope that my screen session actually is still live. So I've got a couple of images here. So the first, for those who don't know me, I think that octopodes are the coolest animal ever. This is a 3D printed octopus that's very metal. And we're going to send this to the API, or across to our app. I didn't send this through the If You Should Hug It app, so I can't speak to whether you should hug it. It's very sharp, so I wouldn't recommend it. So let's see. So I was in Carter's session earlier and about debugging. So let's see if I have to make use of any of his techniques. We can. OK. I was going to pray to the demo gods, but apparently we don't need to. So is that big enough for you to see the response? And can I actually make it bigger? No, I can't. Oh, that's fun. So let's just copy that. And make that bigger. So as you can see, it actually did a really good job at identifying that this was a cephalopod. Curiously, the lowest of the 3 scores was for octopus. So maybe it was unclear if this was an octopus or a giant squid. But the one that really impressed me was the marine invertebrates, because that's a pretty large class of potential animals that could be. So I was pretty happy to see that particular result. OK. So let's do another one. I could have rigged that one up. So the other one, I was like, well, what should I do? We've got this nice, brilliant picture of our dice. Let's see how good the API is. Does anyone have any predictions about what it'll return? Jelly beans? I'm hungry. Anybody else? Ice cream? Oh, ice cube. Oh, that's a good guess, actually. They do kind of look like ice cubes that you would make for a party. So let's go ahead and test this out. I'll do my nice copy and paste trick again. So we have seen that the app does, in fact, work. and it's showing that this is one of the interesting cases where we do, in fact, have no dice. So as you can see, we only got 2 results. That was a very, very long setup for that joke, by the way. We only got 2 results, which means that we didn't limit any. We only got 2. And we got 1 for brand and 1 for writing. And as far as confidence scores go, these are pretty low. If it found anything, I would expect it to be a little bit higher. So I'm trying to see, OK, it actually did get writing. That's not the primary feature of the picture, but that has better eyes than I do. Let's put it that way. And I'm not really sure where the brand came from. So we'll have to plead ignorance for that one. So it's not infallible. We do have instances where we could stand to improve with the model that we've built. It's a matter of well, we may have trained it using a lot of images, but there are always more images. For instance, my phone. It could, no, I wouldn't want it to train from pictures on my phone. So let's scratch that idea. So one interesting note is when people tend to ask me about machine learning APIs as a service, the question is, does it use my data then to provide feedback to the model? Because one of the cool things about machine learning is that typically, if you're developing a model, you can then make it better by retraining it. These training steps use a lot of data. They throw it at an algorithm in batches at a time, and you can always go through and make it better using feedback. So the answer to the question about the Vision API is unfortunately no. Fortunately or unfortunately, depending on your viewpoint. No, we don't. We may, in fact, tune the model as time goes on, but not with the images that you've provided to it. So those are my 2 demo images. So let's hop back to the slides. So there we go. So as I mentioned, this particular application took me about an hour to write. 2 API calls, basically. And I was able to develop something that is remarkably stable. I'm always surprised when my code is stable. And it does a pretty good job of answering basic questions about what might be in your images. But so it's pretty cool, but why? Why would you do this? What are the potential applications for something like this system? So I thought I'd take a minute and talk to you about the cool ways that machine learning could make an impact in our lives with Twilio. I tend to make a lot of things that don't really have a lot of use afterwards, like machine learning and whiskey. It's just that the data isn't there yet. The data will be there. So I'm a tourist right now, a little bit. I haven't been to London in like 10 years. So one of the things that the Vision API can do is landmark detection. So you could build kind of a naive app that helps people navigate and do landmark recognition just by texting. And you can make it a little bit more intelligent on the back end by then providing assistance in where they should go next, interesting facts about what they're seeing, but it would be in a very intuitive way. So I still receive a lot of physical mail, and one of my anxieties whenever I travel is, am I going to miss a bill that isn't yet delivered electronically? I know this problem is going to go away soon. Still causes me a good deal of anxiety. But I could build a little bot that sorts my mail for me, uses OCR, and texts me who's been sending me mail. It would, unless I wanted to arm the bot with a letter opener, it wouldn't be able to tell me what's in it. And I think I've seen enough badly implemented robots to know that I shouldn't do that. This is actually something that I did some research in a long time ago, which is how to help people that have low vision navigate the world. So say that you are looking in your cupboard for cans of food, and they don't have Braille on them. So how do you determine which is which? Take a picture, maybe put some fancy image stabilization in there too, and then send it off, run OCR, and send it back. It's a very basic way that you could have an impact in a very profound way. Pardon the contradiction in words. Sentiment analysis is one of those cool things that some people are really good at it and some people aren't. So if you're trying to help people interact with others better, you could help them take pictures, maybe grab stills out of video, send them to the API, and try and get some information about how people are feeling. Are they happy? Are they angry? He's very happy right now, I can see. I think. I need to make an API call to make sure. And then one of the things that I just rewrote now, which was those conference scanner apps. You could provide some really interesting high-level statistics about which companies are showing by running OCR or logo detection on the business cards. You could say, well, there were 3 people from Google there because I scanned 3 people's business cards. They all said Google. There are 3 of us. So there are a lot of different ways that you can incorporate machine learning into your applications to make them more effective. And since you're all here and you're developing Twilio applications, I hope I've given you a few at least basic ideas. All of you probably have way more creativity than I do, so you'll come back and tell us what you've built. So more information, our developer documentation as well as the code from today. Someone did some great work to make it run in a distributed fashion with Kubernetes, which is up there. Scale all the things. And thank you so much for Twilio for having me. I really enjoyed coming to talk to you. Thank you.